Hello and welcome to this Level 3 Mathematics in Context training video for Pearson Edexcel. In this video, we're going to look at compound interest. The specification reference says that we should set up, solve, and interpret the answers to growth and decay problems, including compound interest, calculate simple interest and compound interest, use and interpret graphical representations of simple and compound interest. There are no relevant formulae available in the formula booklet for this specification reference. Is the mapping document mapping the content of the core mathematics in context references to the GCSE and GCE. Let's think about some ideas for teaching this in maths in context. You are probably aware of the idea of a savings account as a good way in, but other ideas include property appreciation. So the value of property often appreciates over time, and students could look at historical house prices and see if they can model the value as a compound growth. Similarly, population growth, a population of countries can experience compound growth as each generation gives birth to the next. The larger the population, the more people there are to contribute to future growth. Key skills for this reference include students should be familiar with the use of exponents for repeated calculations, and students should be able to determine when a described situation fits a growth or decay model. Let's take a look at an exam question. Hannah invests X pounds in a fixed rate bond for N years. The fixed rate bond pays 1.5% compound interest per annum. V is the value in pounds of the bond after N years. Now write a formula for V in terms of X and N. 2 marks. So we're going to need a multiplier. So if we're increasing by 1.5%, if we think about starting with 100%, adding on 1.5% is 101.5%, and then as a decimal, that is 1.015. So that is going to be used for n years. So 1.015 to the power of n multiplied by the original investment rate of x, and then just remembering to write it as a formula. So v equals 1.015 to the power of n multiplied by x. So the mark scheme gives 2 marks for that. You can get 1 mark if you've got the incorrect multiplier, but everything else is correct, or you've not included the v equals part. And the examiner's report says that the majority of candidates answered part A well, with many fully correct answers being seen. The most common cause of lost marks was to provide a formula using an incorrect multiplier, such as 1.15 rather than 1.015. Or showing a formula that used addition rather than multiplication. Here is another part of the question. It shows 4 graphs and then it says, write down the letter of the graph that best represents the value of the bond, V pounds, after N years. So this might be an unfamiliar context for students. The concept of compound growth is that the amount it goes up by increases each time. So graph D is the one we're looking for here, where the gaps between the heights of the bars is increasing each time. So mark scheme, single mark of this one, have they correctly chosen graph D? And only about 50% of the candidates correctly identified the correct representation. So this is one of those things that students don't often see, and perhaps you should incorporate it into your teaching. A different exam question says, Sarah is going to study for 3 years for an accountancy qualification. She has to pay a tuition fee of £1,500 at the start of each year of study. Sarah will borrow £1,500 from her bank at the start of each year of study. The bank charges 6.1% compound interest per annum. Sarah will pay nothing back to the bank until the end of her studies. Part A, work out the total amount Sarah will owe the bank at the end of the 3 years for 4 marks. So think about how to answer this. So I think it's useful to consider each year at a time. So in the first year, Sarah is going to borrow £1,500 and she's going to essentially have that borrowed for 3 years. So the money she borrowed at the start of the first year is £1,500. It's going to have an interest rate of 6.1%, so 1.061 to the power of 3, because she's borrowing that money for 3 years. The second year, The money she borrows at the start of the second year, well, she's only borrowing that for 2 years. So the index is only a 2. And then the third year, she's borrowing that money, the 1,500, she borrows that for 1 year. So the index of 1 isn't necessary there, but helps demonstrate the pattern. So the money she borrowed in the first year ends up being valued at £1,791.58, and so on for the other ones. So her total amount that she will end up owing is £5,071.67, just adding up those three values. Mark scheme for this question, essentially 2 marks, method marks for any of those values, including a power of 1, 2, or 3. 1 method mark available if one of them is found correctly. A further method mark for complete method to find the total, and the accuracy mark of £5,071.67. So examiner's report says that this is often attempted very well. Some students were able to work out how much the initial £1,500 would incur in interest, but were unable to deal with the additional borrowing each year. Generally, students were using the correct multiplier, and then a small number of students did calculate compound interest of 6.1% on the £4,500, sort of misreading the question a little bit there. Some top tips for teaching this. So take care with the multiplier being used. Students are often good at that, but it's definitely well worth revising and revisiting multiple times. At this level, the setting's often more unfamiliar than at GCSE, and you saw the question just there that had multiple steps to it. Consider the value of n carefully by checking the time periods given in the question. The ones we saw had year time frames, but it could be other things like weeks or months or other time frames. And students are generally more comfortable with scenarios which include growth, so ensure that they have had experience of dealing with ones where it's decay or depreciation as well. Thank you for listening to this video. I hope you found it useful.